Hi, today is April 9th, and our goal today is to review problems from the practice assignment for the last 2 days. So thank you to those of you who, first of all, watched the videos, practiced the work, and then gave me feedback on the Google form. That really helps me to know how to spend time on these videos. So just to comment on a couple of the comments. So first of all, the highlight of my day was reading the part of it that had to do with the compliments that you had for other people. So thank you for looking for the good in this situation and making sure that you're sharing your gratitude with other people. I also, in the comments, read a couple things that I just want to comment on. One of them is that the videos are too long, and I will tell you, I absolutely agree with you. Like, I bore myself making these videos, so I really apologize. I will try to do the best I can to speed them up. I'm going to do the best I can at the beginning to tell you what's coming up so that you can fast forward if you need to. So I need you to like use them in a way that's useful for you. And I'm so sorry that they're boring. I just don't know how else to do it. So please stick with me and know that my heart is with you, and we're doing the best we can, and I'm certainly open to specific suggestions at any point that you have them. In this video, I'm going to do 6 problems, so they're listed here in the order that I'm going to do them. So, for example, if you said, I had no problem with 10.2, then you're going to want to look and fast forward to 10.1. I'm going to label the top of each little section with the problem number so that it makes it easier for you to fast forward and find the right spot. So the first problem that we're going to do is from lesson 10.2, problem number 7. So in this problem, I have the square root symbol isolated on one side. So once I have that in place, I can go ahead and square both sides. So this is a property of equality that allows me to square this side and then allows me to square this side as well. So I end up with that. Then I need to put it into standard form. So I'm going to do x squared minus 12x plus 32 equals 0. Next, I'm going to think about the different ways that I can solve that equation, and something jumps out to me right at the beginning that tells me that I can factor it. So I'm going to put the 32 here and the minus 12 here. And what jumped out at me was that I know that 8 times 4 is 32, and 8 plus 4 is 12. So I need this to be a negative and that to be a negative to make this a negative. So once I factor it, then I know that x minus 8 times x minus 4 is going to equal 0. Therefore, x equals 8 and x equals 4. And those are my solutions for that square root function. Because of the possibility of extraneous solutions, I should also check my work. So I'm going to plug the 8 in for x in both places. 12 times 8 is 96. 96 minus 32 is 64. And the square root of 8 is 8. So that one's okay. On the next one, I've got 4 equals the square root of 48 minus 32. And 48 minus 32 is 16. So 4 does equal 4, and that one is okay. On to problem 10.2, problem number 8. Again, I have the square root symbol isolated on one side. So once I do that, I can square both sides. So when I square this, I get simply 4x plus 13. When I square this side, keep in mind that when I square it, it's this. So I have 4x plus 13 equals x squared minus 4x plus 4. So don't forget that middle term. Then I'm going to put everything in standard form. I'm going to subtract 4x from both sides. And I'm also going to subtract 13 from both sides. So I'm going to end up with 0 equals x squared minus 8x minus 9. Then I'm going to go ahead and solve that equation. And again, I can factor it. So I've got negative 9 and negative 8. Negative 9 times 1 equals negative 9. Negative 9 plus 1 equals negative 8. So my solution is x minus 9 times x plus 1. So x equals 9, and x equals -1. And again, because of the possibility of extraneous solutions when I'm solving these equations, I definitely want to check them. So I'm going to go back to the original equation, and I'm going to plug in 9 for x. So 4 times 9 is 36 plus 13, and that's going to equal 9 minus 2. So 36 plus 13 is the square root of 49, and that does equal 7, so that one is good. On -1, I'm going to do 4 times -1 times, so this side I have -4 plus 13, which is equal to 9, and that is equal to -3. But the square root of 9 is 3, and that does not equal -3. So this is an extraneous solution. Even though we could say that the square root of 9 is also a -3, if you keep in mind on these on square root functions, we don't use the negative roots, so that is going to tell me that this is an extraneous solution. I would not get too hung up on the whole extraneous solution thing. Try to check it, try to make sure it works, but if you're having a hard time with that extraneous solution, please don't worry about it. It definitely is an advanced part of this skill. For extension 10.1, I'm going to do 4 problems, and I'm going to label them at the top of the page. So if you don't need problem number 5 and you want to just fast forward through this part of the video, you can get to the problem that you would like to see me go over. So problem number 5 is the square root of a fraction, so we know that we can't have that when we're simplifying. So the first thing I'm going to do is split it into the square root of 5 over the square root of 12. I'm going to take the square root of 12. Actually, so I have 2 choices here. I could take the square root of 12 first and then rationalize it, or I could rationalize it and then reduce it. So I'm actually going to rationalize it first and then reduce it. So I'm going to multiply both the top and the bottom by the square root of 12. That's going to give me 12 on the bottom and the square root of 60 on the top. When I do the square root of 60, I know that that's going to be 5 times 2 times 2 times 3. So there's the 5, and then I'm multiplying it times 12. And I know then that I need to simplify. I need to take the square root of that 4. So this is going to be 2 times the square root of 15 all over 12. And then I have to look to see if I can reduce, and I can, so I've got the square root of 15 all over 6. And I have fully simplified that rational expression. This is extension 10.1, problem 9, and I have 2 terms in this expression, but only one of them has a square root symbol, so I'm going to start by simplifying this. I need to rationalize that denominator, so I'm going to split it into the numerator and the denominator. Then I'm going to multiply times the square root of 21 and the square root of 21. So on the bottom I get 21, and on the top I have the square root of 64 times 21. I know that I can take the square root of 64, so that's going to become 8 times the square root of 21 all over 21. I double check and see if I can do any simplifying here, and I can't, so that term is now fully simplified. I really could have at the beginning taken the square root of 64 and made that 8 right back here, and that is probably what I should have done. I just wasn't paying attention to it, so I didn't, and I can do it at the end. Again, a lot of flexibility in the order in which you do these things. Next up, I know that I'm going to subtract 1/7 from it, but I know that in order to subtract a fraction from a fraction, I need a common denominator. So I'm going to change 7 into 21. That makes my numerator 3. And at that point, I don't have like terms. So this has a square root of 21. This does not. So there's nothing I can do to simplify when they don't have a like term. So my numerator becomes 8 times the square root of 21 minus 3 all over 21. And I am done simplifying that expression. Next up is problem number 11, and this is an expression with a radical in the denominator with another term. So this is when I have to use the conjugate to simplify that denominator. So I'm going to multiply by the conjugate, which is always going to be the same terms. opposite sign. So if this is plus, this is going to have to be minus. And if I multiply the denominator by that, I also have to multiply the numerator by the same thing. The numerator becomes 3 minus the square root of 2 because it's just being multiplied times 1. And then the bottom becomes 9 minus 2. So I'm doing my first terms. My inner term and my outer terms cancel each other out. And then my last terms multiply to minus 2. So then I'm going to just simplify that. 9 minus 2 is 7, and I'm done. Finally is extension 10.1, problem number 13. Again, this is one with a binomial in the denominator, both with radicals. So I'm going to multiply by the conjugate. Conjugate is the same terms, opposite sign, and I'm going to multiply the numerator by the same thing. In the numerator, I'm multiplying the 15 times both of those terms, so I get 15 times the square root of 6 minus 15 times the square root of 13, and that's all going to be over 6 minus 3. So keep in mind that square root of 6 times square root of 6 is just 6. Square root of 3 times square root of 3 is just 3. Because they're both square roots, I don't, like, neither one of, this is not 36 and this is not 9, because I had square roots of both of them. So that's going to simplify to 3, and I know that 15 over 3 and 15 over 3 can reduce, so this becomes 5 times the square root of 6 minus 5 times the square root of 13, and I am done, and that was my last problem for today. So hopefully that helped, and again, thank you to those of you who gave me feedback so I knew which problems to work for you.